Hi, I'm Jonathan Gardner, and this is the third video in the series on my C Algorithmic Trading Bot. So I've got my VS Code open here. We're going to dive into the code today. Before I begin, I just wanted to show you a very fundamental function of this entire app. So the app really only runs when it's receiving price updates, whether it's through a mock socket or a real socket. It needs to receive price updates through a socket. And it calls this function, and this function is the one that processes each one and decides whether it's going to place orders or not. So just wanted to show you that that function is at the core of this entire app. And that kind of brings me to this first topic, multi-threading. So if I pop into my app.cs, so this is the app, the thing that only cares about today kind of thing, and this run async method runs once and it runs all day. So it's going to start running, it's going to connect to the socket and everything. It's just going to keep processing price updates via the trade engines on price update function until either the socket runs out. So that would be in the case of a mock socket if it runs out of price updates, or it reaches market close time, which I've defined in my app settings class. Okay, so let me just walk through this. This is just starting a stopwatch for debug purposes. This just prints out something also for debug purposes, and it only prints that out if you've got the debug log on. There are different logging modes that turn different logs on and off. Here is where I want to talk about. So these are two disposable resources that are created, and then I tell this managed resource utility that I created these disposable objects. So informing the managed resource utility that created these disposable objects ensures that they will be disposed of properly. Even if an exception is thrown or something like that, they're going to be disposed of. And in fact, at the end of each day, it's not in here, but after this function completes at the end of each day, the app runner will dispose of all of the disposed objects. So in the main project, in production, it's just going to run, 1 day a day. But if you're running a test over like 2 years of data, it's going to go through 1 day in like a second, and then it'll start the next day. So at the end of each of those days, it will dispose of all the disposable resources. And there are really only two in the app. And there are really only two in the app. There's this socket listener and the price update socket. So the reason I needed the socket listener, which its full name is sequential socket listener, is because the socket from Alpaca is going to send me multiple updates, possibly all at the same time, or maybe just like super fast, close together. And I want to process one update at a time. So when I'm calling this function, I want to call it and let it finish before the next time it's called. The socket won't allow for that. It's just going to send them whenever it gets them. So that's why I need the socket listener. I just wanted to explain why that exists. So first, these three lines are interesting and they're kind of out of order. So before I get too deep into that, I made these little notes to help explain what's going on here. So the price update, what I'm going to do is I'm going to connect to the Alpaca socket, and the price update socket is going to subscribe its onReceived function to receive the updates from Alpaca. Then the sequential socket listener is going to be subscribed to the socket and its in-queue update. So this price update socket is, once it receives an update, it will call into this subscribed in-queue update function in the sequential socket listener. Now, the first two lines in this, these two functions are not async functions. They both just execute immediately. So this one receives a function, receives an update, and this one, and it calls into the in-queue update function, which then adds that update to a growing queue. And then it immediately returns. It's not async. And then the next thing that happens is that in a new thread, the updates in the queue that exist in this sequential socket listener, so it's adding all these updates to the queue, in a new thread, the updates in the queue are processed by the socket listener's main method. And I'll show you that in a minute, but I just want to go through this. And then that calls into the onPrice update function that I was showing you initially, the kind of core function, and it'll do that one at a time. So in a new thread, the updates in the queue are processed one at a time by the main function in the socket listener. So it's on received to enqueue update into that main function and then to the onPrice update. And that might seem a little bit overly complicated, but it allows for looser coupling of the code, so you can kind of change out your own price update socket and it'll fit right into the existing code very easily. So just wanted to explain that first. Okay, so that's what's happening here. So the socket listener, we say, hey, every update that the socket listener gets, pass them to onPrice update, and hey, every update that the price update socket gets, pass them to enqueue update. So that's basically what I just described to you. Okay, and so if I pop into that, it's going to be this weird abstract class with just these two functions that are abstract functions, and it implements disposable because this is a persistent connection, so it needs to be disposed of. So I've encapsulated all that kind of disposal logic in this disposable class. But if we want to see what the actual implementation for the main class is, or sorry, for the main project is, it's here. This class inherits from the base class, and then the test class will also have its own mock price update socket, and it also inherits from the base. Okay, so in this actual implementation of this base class, where I just have these two functions exposed, this connect and then the subscribe for symbols. The connect is just passing my credentials and getting authenticated, and then the subscribe for symbols can ingest a list of symbols and subscribes to several data streams, one for each symbol, to get price updates, and it subscribes its own onReceive function, which I was discussing earlier, and then it comes to this line that actually kind of subscribes to the socket, and the sockets will, after this line, the socket will start sending updates. Now, importantly, it doesn't just sit on this line while updates are coming in. What the SDK does for you, and it's not in this code because the SDK does it for me, it'll kick off a new thread. So actually this function immediately returns. So if we go back to where it was called, like this is immediately going to return, but it's going to start sending updates to enqueue update, and then enqueue update is going to indirectly send them to onPrice update. I'll show you that in a moment. And then it's just going to get in this while loop, and it's going to, every second, it's going to say, hey, should I stop? Is the socket done? Or, so are there more price updates to process, or, is it time to stop? Okay. So now that we've discussed that, I wanted to show you what the socket listener looks like. Well, first, let me just point this out, that this onReceive function just kind of packages the price update up for you so that it's in a form that I've defined in this project rather than Alpaca's defined form. And then, so let's pop into this socket listener. So the socket listener has this enqueue update that is not an async function, and all it really does is just enqueue it, and then it says run if not running. Now, importantly, that run if not running function is not defined anywhere in this class, and that's because it's defined in this parent class. And again, similar to the disposable, I've encapsulated this kind of sometimes confusing logic of like when to run threads and dispose of threads and things like that. So basically, Threadable takes care of ensuring, and it says it right here, since this class inherits from Threadable, it will never have more than one thread running at a time. So when I say run if not running, it's going to run the main method here if in a new thread if a thread is not currently running, and if a thread is running, it's just not going to do anything because this main method is already running. And what this main method do is it says process everything in the queue. So whatever I've added to the queue in an in-queue update, I say run if not running, and it's either already processing it, already in this while loop, dequeuing stuff from the queue and sending it to the subscribed function, which in this case is the onPriceUpdate function that I was saying was at the center of the application. Or if it's not already running, it'll kick it off and it'll jump in here and start running this while loop. Now you might wonder, what is this line about? This await task delay, like why am I slowing down my application on purpose? The reason is because my code, I've written it to short circuit really quickly. If there's nothing to do on a price update, it basically returns immediately. So it's very fast most of the time, because most of the time you're not going to do anything on a price update. You can get tons of price updates, like one every millisecond, and most of the time there's nothing to do, so you don't want processing a whole bunch. So it's very fast, and it'll easily get ahead of the updates coming in the queue. So what happens, since it is so fast and it does get ahead of them, it's going to process one update, it's going to get done with it before it receives the next update, and then it's going to dispose of the thread. And so this new one's going to come in and say, oh, there's not a thread running, I have to start up a new thread, then I'm going to dispose of it, then a new update comes in. So it's just creating and disposing a lot of threads, and that's just unnecessary. So I let it go ahead and pile up a few price updates before it even starts processing things, so it's not creating and disposing so many threads. Okay, so that has been explained, I hope. Pub sub design patterns, so let's pop into this app runner base. So this is also one of the things in the app that I'm very proud of. So this is the app runner. This is the thing that wraps the app. And the way I've written this is that the app runner has a bunch of functions in it. So this is a function that it is subscribing to an event that is fired off by the app. So the app at the start of every day will fire off, will publish a message to a topic, and the topic in this case is after start of day load, and it basically fires off an event saying, hey, I've loaded the data, the persisted data from the previous day, and I'm ready to start processing. I'm just about to start. And it calls into this function, and at that point you can do things like logging, you can do validation, you can set a breakpoint for debugging purposes. And what is really nice about these is they have full access to the app. So I've got the app here, and the app has full access to the engine, and the engine has full access to all the positions and stuff. And you might say, oh, those should be private variables, you shouldn't be able to modify those directly. I come from a Python background, and this is not an enterprise application. This is an application that I wrote myself. So these are public, and you can hate it if you want, but it does make stuff like this nice and easy because back in the app, back in the app runner, I can hit one of these events in here, and I can do logic like sell off my position if I want to. I can cancel an order if I want to, things like that. Now, I wouldn't recommend it, but I'm just saying you have full access to do anything you want from here, but mainly I use it for logging and validation. But as you can see, there's lots of different events. I fire one off at the end of the day, at the beginning of the day, every time an order action is done. So that's like if an order is filled, if an order is placed, if an order is canceled, blah, blah. Position renewals, I'll quickly explain that. So anytime I sell off, let me say it this way. Anytime I start a day and I'm holding no quantity in a position. So I don't own any of the stock. I renew the position. You can also consider it a refreshing the position, because there are two different types. There are two different scenarios. There are kind of renewal propers and position refreshes. So if I never bought a position, so let's say I have my primary orders, I start on day one, I have my primary orders, and none of them execute. So, I've got them set too low, I'm waiting for it to drop 2%, and it just never drops that day. Maybe the stock goes up. None of my primary buys get executed, and I never buy any of the stock. So it'll save off my position, it'll persist all the data, and then the next day it'll load it up and say, oh, I didn't buy anything, I'm not holding any of this. It's going to refresh the position at that point. It's going to say, let's get rid of these primary buy orders that I had and that old basis price. I'm going to set a new basis price that's yesterday's close price. See the first video if that's the first time you've heard this. But yesterday's basis price is, or the last trading day's closing price is the basis price. So it'll choose a new basis price, and it'll choose a new array of primary buys. That's a position refresh. This action will be fired whenever that happens. The other time that this action is fired is when you actually did buy some of the position, but then the price goes up and it sells off all of the position that you had. That's what I call a renewal proper. And I know the language is a little bit confusing because this position renewal is referring to refreshes and renewals, but this is a work in progress. Hopefully I'll fix it later. But anyway, so anytime you are not holding any of a stock at the beginning of the day, this action gets fired. Okay, and then at the end of a price update round, so this one's every millisecond. If you're getting a price update, this event is going to be fired like every millisecond. So it's fired a lot, and it's very useful for debugging purposes. You can put a breakpoint in there and really step through it one price update at a time. You can put logging in there, etc. And then on account balance update. So anytime an order is filled or something like that, the account balance is adjusted, and that is called. Okay, let's return to this. So I've discussed the pub sub design pattern. Oh, and there was one more thing I wanted to say on that. So if I go to before end of day save, and then I look in my mock app runner for that, so you can see that I've overridden that function here. And then I actually call into the base. So what I'm doing is I'm adding a little bit of logging without needing to modify the base function. So I can leave this function exactly how it is, and in my mock implementation that sits on top of kind of the base, the parent class, I can put extra logging, I can put extra validation, I can put extra logic of any kind, I can put a breakpoint, whatever I want, without having to modify the base class, which is nice. So that makes it very extensible and easy to, kind of manage. All right, so logging and the app initializer. So let me pop into the test projects program.cs. So this is the entry point for most C# projects, is the program CS at the root of the project. And so this app initializer is basically just exposes this init function, and it accepts command line arguments. I can set the runtime environment as test. In the main project, the runtime environment is set to prod. And then the brokerage API environment. So even in prod, or even in the other program.cs, I can play with play money. So I can connect to Alpaca exposes an API where you can actually send messages to their brokerage API, but you're just playing with your play account. Your paper account is what they call it. So that's really nice. So this kind of controls whether I'm playing with real money or fake money. And if I pop in here, what you can see is, first of all, I'm saying anytime I control C out of this thing, I want to make sure I dispose of my disposable resources. Sets the runtime environment, sets the brokerage environment, handles the command line arguments. So I can send in options to set the logging level. I can pass in options to delete old logs and old persisted data. So this -D will delete both logs and persisted data, or if I just wanted to delete logs or just persisted data. And then I can also pass in other options for different run modes. And in production, there's actually only one run mode right now, and it's just running it for a day. But in the test project, in the main project, there's only one run mode. But in the test project, there's many different run modes. So I can run a single simulation, say for like a year of data, to see how much it would have made in a year. I can run multiple simulations to test different parameters and different configurations of my parameters that I feed into my algorithm, so I can do it for the same span of data, say 2019, and I want to trade SPY. So I can run a simulation for the entire year of 2019 on SPY with many different algorithm parameters and see which one maximizes my gains. So that's what this is for. This one is just to run your unit tests, and then this one is to pull more mock data. So, and it's really not mock data, it's historical data. So if you do a -- pull data, going back to this program.cs, it's going to pull the data for this time period and these symbols so that you can use them, and it's going to put it in a folder. Whatever you define here will be the folder that it's stored in, and then you can use it later if you want. Okay, so I went over the initialization. Another thing the initialization does is it initialize the loggers. So there are different log modes: default log mode, quiet, talkative. Like I was saying, you can set them with these command line options. And this might look a little bit repetitive, but the reason I did it this way is that way I can turn a log on or off. I can say for this log mode, this log should be on or off without affecting any of the other log modes. So that's nice. Okay, and so I wanted to keep going through this program.cs. So after you initialize the app, I turn off the stop time. Like I was saying earlier, it stops at the market close, but if you're running simulations, you're not going to stop at the market close. You're going to run the simulation for a year of data, and that'll take like 20 minutes, and then you're done. So this will define the data set of mock data or historical data that I'm using. It could be mock data in here, but all I'm using right now is historical data. And then I'm defining the time period that I want to run the trader for, the symbols that I want to trade. I start a new app runner. I'm not going to go into these in this one. I will briefly show you. So these are the parameters I've been talking about that define how the algorithm behaves. And these functions are pretty simple. This is it. And it's literally just defining, this is how my primary buys are going to be. This is how much I'm going to wait for it to go up before I sell. This is how much I'm going to wait for it to go down before I buy it again. And, this is my break-even sell parameters, where it's triggered, where the sell is placed at, etc. So I'll explain all that next time, but suffice it to say that these are pretty easy, and you can define them on a position by position basis. So if I'm bearish about SH, the inverse to the S&P 500, then I'll pass in the algo params that are optimized for a bearish outlook. These params are optimized for a bullish outlook, and so on. And then this run mock data simulation. So this will go through from the start to the end date. Let me close that. from the start to the end date, it's going to just go through each of the days, and it's going to create an app from scratch because the app only cares about today. So it's broken down and created from scratch every time, and then it runs it for that day. But the entire time, the app runner is going to keep track of everything that's happening, because whenever an order is filled, for instance, it calls this on order action function, and that order action like kind of event handler is going to add the order action to its growing list of order actions. And then at the end I can just say, okay, let's see what all the orders that were filled were, you know, what their prices were, what their quantities were, add it all up, see how much profit I made over the entire time. So even though this is breaking down the app completely and recreating it on every day, the app runner is what keeps track of the information over multiple days via those kind of event handlers or hooks, you could consider them, or, you know, subscriptions to topics. Okay, data persistence, just these last parts will be really brief. In the output, so I have different output for kind of prod, or the main project, and the test project. So in my test log, there's the test logs, and then there's the persisted data. So first, I'll just show you the persisted data. Is like I have persisted data for each day that the trader ran, and you can see it's skipping a few days here, but that's the weekend, and it persists basically all the information it needs to load up the next day. And it's not obviously saving it to a database, because I thought that was overkill for this project. It's just serializing and deserializing it. And then here are also my logs. I just wanted to point out really quick that it looks like I have a lot of different log files here, and like, why don't you just throw it all in one log? Well, part of the reason is because a lot of them are tabular like this, and so the data has different forms, and I couldn't put all those different forms of data in the same log and have it be a table like this. So I think this is really nice. This is excellent for debugging. It really gives you good visualization into what's going on. These are all the API requests I'm sending to cancel orders, to place orders, to get the order statuses, to get my account balance, etc. It's my debug log, and it's huge. Because I just ran it for a year of data on debug mode, which I wouldn't normally do. Like, normally if I put it in debug mode, I'm gonna short circuit it. I'm gonna find the bug and then stop it. That's the error log, etc. And those are not real errors. These are really just screaming that the data that Alpaca is sending me is questionable. Their historical data. Okay, and then I want to go over the resource and exception handling. So let's go back to this common folder, the utils. So this exception utility. So anytime an exception is thrown, I can just add the exception to this, and it's going to add it to its queue. And you can see that these are static. This is a static class, and these are static variables. So anywhere in the code that has an exception, it can add it to this, and everywhere in the code can see that an exception has been thrown, and then the code will short circuit and stop. But before it stops, it's going to log it to your error file so that you know that it happened, which is nice. And just as an example of that, you can see in the program.cs, you can see I've got it surrounded by this big try catch finally block, and if an exception is thrown, the exception util adds an exception, and then it throws it to just stop things, because we don't want things to continue processing when an exception was thrown. And then managed resource util is also a static class. Well, I guess it's not a static class, but it's full of static variables. And so anytime I create a resource that needs to be disposed, or, anytime I have a resource that needs to be disposed, which includes things that run on their own thread, it's added to this, and then it makes sure everything's closed out and disposed of properly. Oops. Okay, and then the last thing I wanted to go over is the Docker file, and just I just quickly wanted to point out this thing has been Dockerized, so you can easily deploy it to the cloud and all of that. And I've successfully deployed it onto AWS myself, and it totally works. So feel free to use that. Okay, and then so in the next video, I'm going to go over the algorithm configuration. So I'll see you there.